Helena Sullivan. Helena is currently working as a construction supervisor for a local agency in the northwest suburbs of Chicago, Illinois. Topic is Small but Mighty McHenry County's Bridge Inventory and Preservation Program, a summary of local agency bridges and recent projects.
Well, thank you everybody for attending. I'm here to tell you a little bit about our program. We are a small agency. We have a staff of about 20 engineers and maybe 40 highway maintainers, but somehow we get it all done. So a quick touch up on me. Like I said, I've been there almost a year and I love my job. I have a great supervisor. He's very supportive, very flexible, and he's also been there about 11 years and he's done a lot of things during that time to help improve our programs. But I'm somebody who makes a really good right-hand person, so I'm trying to steal his work. So here I am, learning about bridges and trying to get a better plan for our preventative maintenance. We have bridges that are being rehabbed or replaced, but why not look at the ones that are, on the higher end of the structural deficiency, like the 6s and 7s? Can they stay there longer? Before I worked at the county, I spent a couple years as a teacher, high school level, seniors. That was hard, but it was interesting to try to provide motivation to pursue engineering. And one of the things I did is I taught a class called Civil Engineering and Architecture, and during that class, common theme again, I had the students look at significant bridges, but I told them, let's not all do the Golden Gate. Pick something more unusual or more unique. And one of the bridges that I shared with them was a bridge that I've traveled across several times, which is the bridge that connects Denmark to Sweden. If anybody's familiar with this, half of that bridge is a tunnel. It starts off from Denmark and comes up on a little man-made island and then continues into a steel span bridge. It's really interesting. Take a look sometime on Google Maps. My Lake County experience was 7 years of working in design, drawing plans. Again, I didn't draw any bridge plans because I don't have that background, but we had excellent resources. I replaced 2 box beam structures. One was built in the 50s, and that was, I believe, the southbound direction. And then we waited a little longer, and then lo and behold, the northbound structure finally qualified and was structurally deficient, and that one was replaced the year later. So those poor residents, they thought, well, we're just getting a single lane, we're inconvenienced for just one summer. No, it was 2 summers in a row, one direction, one way, and then the following year, the opposite. And my Department of Transportation experience at IDOT was also a bridge. My first job was at an intersection where we built a diagonal set of double culverts underneath the intersection. And that was very interesting because IDOT routes, state routes can't be closed. So that was a very big puzzle to get this construction site and the contractor to build this intersection under live traffic and place these 2 concrete culverts underneath this roadway on a diagonal. A lot of challenges with staging, a lot of small puzzle pieces of concrete, that type of thing. And the following project site that I was assigned to was actually a large steel bridge over a railroad. So I've seen them during construction. I've interfaced with a consultant to draw them. And now, of course, I get to work and oversee some of my engineers that are working on bridge projects. And I'll touch on that in a little bit. So our topics, I'll of course tell you where I am, a little bit about brief history, how old our bridges are, and some bridge types, and then a short slideshow just to give you a highlight, and some projects from last year, and then this upcoming season, and then finally, if you guys have any questions, you can ask. So I live up here in the northern part of the state, and if anybody's been to Chicago, that's great, but has anybody seen the movie Groundhog Day? Right? A few. Well, that was filmed in Woodstock. So that's our claim to fame. We have the Bill Murray movie, basically, there is a Groundhog Day celebration every year in February. So Woodstock takes their square and they celebrate and they have a little festival around that event. So McHenry County is really rural, very agricultural. There's one main corridor that's a 6-lane road, and other than that, most of the other highways are 2-lane, and they carry like farming equipment and there are truck routes throughout different parts of our county. But it's a lot of county highways, which is really pleasant when you drive to work in the morning, I have to say. So this slide, a little bit about our history of bridges in general. The automobile down here in the 1930s, we didn't have too many bridges built in the early part of the century, but as we get into the Industrial Revolution, we have trucks delivering materials. We had a big spike of construction in that 60s and 70s. And then it tapered off. So similarly, our bridges in McHenry County, we have the same kind of trend. In the 60s, we had most of our bridges constructed. So I just wanted to give a brief overview that we had a similar timeline when we had our built bridges to expand our network in our county. So what does our inventory look like? Well, we have an inspection company called Willett Hoffman that does our annual or biannual inspections, and they helped out and put this together. I actually stole a lot of these slides from my supervisor in Willett Hoffman. I'm going to say sometimes, taking the easy way out. But Willett Hoffman does our inspections, and they itemized our bridges in this nice little summary. We have, obviously, almost 50% are the box beam style bridges. And then we have a good selection, or a good amount of them are in the culvert category over here. And somewhere in the middle, we have small scatterings of the steel beam bridges and some other channel beams. This is, of course, the presentation that we just listened to on the culvert lining is of interest to me, because I know at some point this culvert, 6 sets of culverts that are underneath a fairly busy road, they're going to need some attention. We check those periodically. We go out and look to see if they're looking like they're corroding on the bottom. They're holding up fairly well, but they're always in standing water. So unfortunately, it's just a matter of time until these have to be addressed. Do we do a culvert or some other format? It might be less expensive and easier to do the lining process that Scott Kelly talked about in his presentation. So I'm certainly going to follow up on that, and that's exactly why I came to this conference, to see about alternatives. We have about 10 of these box culverts. Some of them are double, some of them are triple. In fact, we had a box culvert right down the road from our office where we replaced the wing walls. They're holding up fine. Most of them are doing a good job, and they're not really creating any troubles for us. But the wing walls on Nelson Road, that one we had the contractor remove the wing walls because they had separated from the edge of the box culvert. So they pulled the old wing wall out. They put temporary shoring in with steel piles, and then they constructed, so they put the temporary shoring up here to hold the embankment, and then placed steel piles exactly in the same footprint where the existing wing wall was on both sides of the road. So now that should hold up a little longer, and the floor of the culvert looks fine. There's some surface cracks that we fixed with epoxy, but overall, now at least we won't have a cave-in. Okay, so this is our flagship bridge. This is the longest bridge in our inventory. This is about 650 feet. It's one of our few steel beam bridges. There's a northbound and a southbound, or I guess an east and a west. Our roads kind of run on the diagonal, so you have to sort of think about, well, which way did the road run before it got to the bridge? That's the direction the bridge is labeled as. So Charles Miller is about 650 feet, and one of the bridges was built in 2013, and the other one I think is from like the mid-90s, somewhere in there. This is a table that just shows those 6 steel structures. I apologize that the font is a little small. But what I want to point out on this slide is the Chapel Hill Bridge, because that's going to get some repair work this season. All the other bridges are relatively new. They're built, like I said, here we have the year constructed. They're built in the 2000s, and then we have this older one from 1990s. So Chapel Hill is in our program this year for construction, so I'll show you some brief pictures of that. And then finally, some of our other categories. We have some pre-stressed concrete beams, not too many of these structures, kind of a smaller span, and some slabs, again, 4 of those. And then finally, our PPC deck beam structures. They range in sizes depending on where the location is. We've got, the 36 or 48 inch, and then we've got the depth of the beams are anywhere from 11 to 42. So it's a wide mixture. I just learned from one of the exhibitors that a possibility for an alternative rather than replacing them in kind with pre-stressed beams and putting that type of technology back in, which seems to eventually fail. He commented that there is a product called Next Beam. So I intend to go look that up when I have time. And then we've got the channel beam. This is actually quite beautiful, but nice long span on that bridge. Obviously, what is it that makes our bridges deficient? Same thing as anybody else. If it's going to be not able to carry the load and the inspection shows a lot of corrosion on the beams or a lot of corrosion on the rollers or the bearings, or of course if you have a lot of spalling material on your concrete so that your rebar is exposed. Or finally, of course, if your substructure is failing. We only have one bridge, I think, that has timber structure, but that one is getting some more regular inspection. So in our program, we've repaired or rehabbed 34 bridges, and we've reduced by 50% our posted bridges. So we're trying to get that number down because the farmers and the heavy equipment are frustrated that they can't use the nearest access road, yet they have to go around the long way. And our inventory is about 130 altogether because we oversee the township bridges as well. We provide engineering and administration for the township program bridges. Depending on what kind of funding they have, they usually use motor fuel tax, and I'll have an example or a case study where I talk a little bit about a township bridge that just recently was done last summer. So our split is about a little heavier on the township side. And then in our inventory at the moment, we have about 20 bridges that are structurally deficient, and 4 of those are going to be under construction this year. So we'll eliminate those, and then we've got 15 left, and all of those 15 are planned in the upcoming years. So we're right on target. I'm excited to say that they're going to be fixed in a very timely manner. Even in the deficient category, they're split, again, fairly evenly between county bridges and township bridges. It's not that the heavily traveled routes are the ones that are failing more. Kind of interesting, just a little piece of information there. I apologize that it's really small, but what I wanted to show with the color on this is the yellow highlighted bars are the bridges that we're planning to go out and fix and rehab this year. Those are currently, they've already been awarded for contract, and they should be starting soon. The green bar in the center is Garden Valley. That's a little case study that I'll share some more details on. Garden Valley was structurally deficient, but we did a bridge overlay, and now it's moved up to a green category. And the pink ones are bridges that are unfortunately still structurally deficient and are in future programs. Here's a little slideshow. This just kind of shows an overview of before and after. This was a single lane bridge with a pedestrian access, and then that's the finished product over here. Alden Road was a really nice little community that you can see is some houses back there. This is a township bridge, so we put some railings on it. Dunham Road out in an agricultural area. You can see the corn growing over here. Put 8-foot shoulders on it, so it's got plenty of width. Lawrence Road, another nice widening. So these will kind of run through. Groff Road, shorter span, so not quite so wide. And this was 2012, so we're coming up. Bliven Road was another nice architectural feature. We stamped the concrete on the parapet walls. And Lawrence Road, do I sound like I'm repeating myself? We had 3 projects on Lawrence Road. Hill Road had some steel sheet piling, which is kind of interesting. Shorter span in the middle. And then Franklin Road Ridge, this house used to flood, so we realigned the whole creek. This project won an award from APWA. County Line used to be a single lane bridge with parapet walls, so you can only alternate one car at a time. So that's the finished product. And then here's another picture of our lovely cornfields right where I live. But the bridge turned out really nice. And then Wilmette Road, we had some visitors that came through the job site after the decking was removed. And I think finally here's Garden Valley. This is the one that most recently was completed. And this was just an overlay project, but I'll show you some construction details that I think you'll find interesting. So Garden Valley it was about $150,000, and it was built in the 60s. It's a box beam bridge, lo and behold. And Garden Valley had an asphalt overlay, and so the recommended treatment was to mill that off and then place a latex concrete overlay on top. And in the process, the consultant recommended for us to fix some of these corroded and spalling areas on the curb lines and seal all the deck drains. So there was some instructions on how to cut the material on either side and make it a larger opening and put rebar in it. So here's our contractor. He's using a jackhammer, and while he was working, he was saying, man, this concrete is some hard stuff. It is really old, and for being this old, it's tough to get off. So he was deleting some of the material that we had marked out on either side of the deck drains, and I said, you know, our plans show to make a tunnel or a hole all the way through underneath the parapet. Why even try to get your jackhammer in there and create all these chips of concrete that are going to fall in the creek? I think we're plenty fine to do just the repairs here and seal it, put the rebar into the deck opening through here, and then across, so the concrete, when it flows into the opening, when they put a board on the backside, has somewhere to flow into, but at least that way you don't have to do all that work to do 24 deck openings through a parapet wall when the curb was even very tough to remove. And then over here you have the forms that they placed and the long rebar that they used to repair one of the longer sides. So then here we remove the HMA and milled that off and discovered that some of the pier joints were a little spalled. But looking at them, we just decided to blow them and clean them up really well, and then decided we didn't want to put a new type of material in there. We wanted the latex concrete to just flow right into those pockets. So this was the most interesting part of this job. Has anybody seen latex concrete being poured? It's green. It's like teal green, and it smells plasticky because it's got latex in it. And then as it starts to cure, it turns this really beautiful violet purple color. Very interesting. It's like, and then this white material here is actually the floating material they use. You can't float it with water like normal concrete where you spray it. You see them mist it with a bottle, and then they use the bowl floats or the regular hand floats. This uses a special liquid on it because the water would just stick to it. And finally, a little picture of the screed. This gentleman here is sitting or walking along on the rail. There was an identical person on the other side, and they had a hand crank, and they were advancing the screed at a continuous speed, but manually, and then it had a little motor here that provided vibration. And as the deck was, a little distant back, then they put a wet burlap on it. So this is what the bridge turned out as when it's finished, and you can see over here are all the closed deck drains. This is quite a steep hill, so that's why we felt that it would be okay to close off all those drains. The water literally just comes down this hillside and runs down out on either side of the abutments. So Carl's Road, again, was a township bridge. This is the other project I'm going to feature from last year. This is an older structure, again, 1950s. It's a deck, it's a full slab. And it's our belief that the rebar floated while they were pouring the slab, so the rebar was too close to the surface. You can see all these lines here, all these ridges. And then, of course, the big holes where concrete was popping out, and they just filled it with some asphalt just to make it a smoother ride. So the recommended treatment here was 2 inches of hydroscarification, and then we did a microsilica overlay. A little picture of the side. The deck drains were bleeding and leaking onto the girders on the beams. So they decided to do a closure of the ones that were in worse condition. So they left a few of the deck drains open, but closed off the ones that were causing a lot of corrosion. But what was nice about this bridge is this is the substructure. It looks pretty nice, right? The rollers are in good condition, and all the beams, all the other components underneath are nice and clean. Maybe we could use a paint job, but that's down the line. So here's our hydroscarification robot. I know we saw a demo of that today. I didn't have to go watch them because I had a job site where they were doing this. They traveled back and forth in a linear pattern, and there were some holes that were blown out. You see some big ones over here. I think the largest one was like 5 by 5 or 5 by 4, something like that. So I marked off where they needed to make square cuts, and then they jackhammered and cleaned off the edges. And then they placed a concrete product in there and brushed it to kind of give it a rough surface. And then finally, here's the bid well that they started on the north end and worked their way south to place the new concrete. We wanted to make sure that the deck had the rebar all the way exposed to almost to the bottom of the bars. So a little over 2 inches. I believe the additional volume of concrete on this ended up being about 30 cubic yards. About 4 inches was placed, even though the theoretical quantity was just about 2. So they doubled their quantity. But that's in our special provisions. You pay the contractor for the additional amount that they needed to bring out, because some of these pockets were really deep. They were like 4 inches when you did the depth checks. So here's what it looks like today. Very nice. This bridge gets maybe 15 or 20 cars a day crossing it. And then if the cornfields are growing corn, you might get some vehicles that are transporting that. But it's not a heavily traveled road, but at least now it's in good shape and it'll last a lot longer. So again, back to my little index, I just wanted to highlight that I'm going to talk a little bit about the yellow highlighted projects. So we're going to show you upcoming projects, which is the Deer Pass Road, Chapel Hill Road, and Bay Road. I just got an email from my construction engineer that Bay Road, the temp signal was installed today. So they're going to start construction of stage 1, which is actually this side of the bridge. You can actually see here that the keyway has failed, and this is the joint that's got holes in it. So I wanted to show you a little underneath and also on the top surface. So they'll be working through maybe June, and at that point, they'll switch traffic and do the south side. But it's $1 million project, and it'll take about 6 months. Chapel Hill Road is a steel beam structure. This one goes over the Fox River. This needs some significant metal work, and they're getting 36 of their roller bearings replaced. So we're jacking this bridge up, and which means that we can't have traffic on it at all. We met with the village in that area and the fire department and decided that the best way to handle is, instead of doing a closure for a week while we're jacking, and then, okay, the jacking is done, we can open, and having the barricades pulled apart and then putting the barricades back, people are gonna get really frustrated as they drive up 1 week and it's accessible, and then the next week it's closed. So we decided to just do a complete 8-week closure, and it starts after school is dismissed. Hopefully we'll get it done quickly, and we're hoping that the jacking can be at a place in the construction process over 4th of July weekend that we can have the bridge available at least that time point, because everybody likes to see the fireworks over the river or in that vicinity. So, and then the contractor is also going to replace 2 of these pier caps. Deer Pass Road is a brand new bridge. We have 2 rivers, or I should say creeks. This is the Kishwaukee River, and there's an existing structure here that's kind of shaded underneath the new plan view. And then over on this side is the North Branch, so here's another small bridge. So Deer Pass is essentially taking out 2 structurally deficient bridges, and then it'll place 1 long span across. This is a pretty big job for us. This is $3.8 million, and it'll take a full year. And then our last project for the season is Oak Grove Culvert. This is just replacing with a 3-box culvert. So I just want to make sure I kind of covered our inventory of 4 bridges and the roundabout. And I didn't mention, but we are widening a large corridor to another lane, and that's a big project. That's a 3-year project, and it's $43 million. But I'm not on that job. On the roundabout is mine. So I hope with this that I've showed you that we're small but mighty. We have jobs that, you know, do a lot for our community, and I'm proud of the involvement that I have. And if anybody at this point has any questions of my job or any of our bridges, I'll be happy to answer.
How is the icing?
The icing on the current bridges? Well, that's why we placed the latex concrete, because that bridge probably had a lot of corrosion on it. Also, same thing, Carl's Road had been salted. Since the townships don't have the same resources that we do, our county agency uses a non-salt option, like the beet juice, or I should say the environmentally friendly option. So when there's a forecast for ice and snow, they'll go out and spray the road, and they have applicators that leave those, like, you know, brown trails on the road. So we don't use as much salt unless it's in an intersection, but over our bridges and over areas that have a lot of concrete, we try to use the beet juice as an alternative.
Typical length of detour?
The typical length might be about a mile, 2 miles maybe. The Chapel Hill goes west and then south and then around. So we try to, you know, post it well in advance to let people know, but a couple of miles usually.
What are your sources of funding that you use to maintain this inventory?
Well, that's another question for me. Essentially, how can we get a little bit more money? We usually use regional funds if there is, you know, somewhere to tap into to get, you know, funding for this. But I know that the 4 bridges that I showed you that's coming, that's under construction, Those are funded with federal funds. We do have some money set aside in our county budget for coatings or maintenance work. I think it's about $200,000. And I don't know exactly which fund it comes out of, but it's obviously our funds. I couldn't tell you if it's like county funds or regional transit funds or something of that.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.